Great, thanks everyone. I hear the green button means go, is that correct? Yes. A few weeks ago, my wife and I were called into the school of my son, who's in grade 5. The teacher wanted to meet with us. And for those of you good at math, yes, that was the first week of school. So, always good to have the teacher call you in about your son the first week of school. But we got through it, issues resolved, no big deal. But one of the things that the teacher mentioned was, your son, he apparently has he has something against teamwork and group work, working in a group. I was like, oh, that's interesting, because he's a pretty outgoing guy, unlike his dad. So I talked to him about it afterwards. I said, what's going on? Like, what's the deal with not liking teamwork or working in a group? Like, don't you, what's the issue with that? And he's like, I just can't get my stuff done fast enough. Like, I want to get the work done and go to recess, but I got to wait for everybody else. And I was like, well, but there's some benefits to working in a team, right? Like, what if the project's really big and won't you get it done faster if, like, you break it up into different people's tasks and then it gets done faster? And he's like, no. I was like, well, okay, but what about, you have to do these tasks and don't other people on the team have some ideas that they can share, and maybe those are ideas you hadn't thought of, and maybe they're good ideas. What about that? No. So obviously we've got some parenting things to work on, and so I'll deal with that. Don't worry about that. But I didn't worry too much because I'm thinking, grade 5 math, not a huge deal when it comes to collaboration or teamwork, right? But if in like 15 years he finds himself working on some super hospital in downtown Montreal on a project team, well, I've got 15 years to convince him that teamwork and collaboration is a good idea. So that's what we're going to be talking about a little bit today. My name's David. I'm from Bluebeam, and with me I've got Lilia, and she's from Noof Architects. Lilia will be introducing herself a little bit more. We've broken the presentation today into 2 parts. I'm kind of the smoke and mirrors where afterwards you're like, oh yeah, I don't believe that can work. And then Lily is going to show us how it really works. But in all honesty, for those of you who aren't familiar with Bluebeam software, our flagship product is Bluebeam Revu. It's a desktop application built for the AEC industry, basically to enable digital workflow and collaboration for tasks all through the project lifecycle. And it all leverages the PDF platform. And then we've got Bluebeam Studio, which is our online real-time collaboration software. And so, how did I find myself here today? Well, I started off in residential construction, moved over to engineering. I was at MMM Group, which is now WSP, and I was there for 7 years, and during that time I found Bluebeam Revu, and it changed our lives. And if you want to know more about that, you can talk to me afterwards. But now I get to travel across Canada and talk to companies and help them improve their digital workflow. And I'll let you in on the secret of our product development. This is top secret, can't leave this room, but we go out and we talk to people in the industry. It doesn't matter if they're using Bluebeam or not, so places like this, and find out, well, what are the pain points and what are the other technologies that you're using and what is it that you're actually trying to achieve. And then we go and develop something, and then we release that and get people to try it out, and we measure the results and basically rinse and repeat. So it's pretty, like I said, top secret, don't tell anyone. Fairly decent strategy. After 15 years of doing that, we've got about 1 million users across the world, so things are going pretty well. But one of those kind of industry engagement types of things, we like to get involved with industry studies. So a couple of years ago, we co-sponsored this study by McGraw-Hill, and what they were doing was asking the construction industry around the world, what do you see as the value of BIM? Like, what's good about it? And so they came up with a few interesting things. So a lot of people really like the collaborative nature of BIM, and okay, no surprise. They say that BIM enhances visualization, right? So you can see a building in 3D. That's really helpful. in terms of, well, I can relate to that because I like to be able to visualize something to understand it. So that one speaks to me. And then finally, a lot more people said that the value of BIM is in the transparency of communication, and helps reduce errors if we can communicate a little bit better between owner and design team, or even designer and contractor. And so, you know, at this point, you're probably saying to yourself, well, like, what in the world is a PDF guy doing at the BIM conference? Right? I'm just going to throw that out there because I know some might be thinking that. And the reason is these three core, what I'll call core pieces of BIM, these are the goals that we've been trying to achieve with our platforms. We want collaboration, we want visualization, and we want transparency, better communication. And so the next question, okay, well, sure, if you can do that with PDF, that would be great. Like, why did you choose the PDF platform? And so there's three reasons. The first reason is that the PDF is an open standard. It's an ISO standard. Nobody owns it. Anybody can program against it, so it's freely available, which leads to the second point, which is that it's universally accessible. So I can send a PDF to my mom, and I don't have to worry about how she's going to open that on her iPhone. I know that she's going to be able to open it somehow, right? So in that sense, it's this universally accessible common data environment. And what do I mean about the data environment? Well, when people think of PDF, they think that was that kind of old technology that was just pushing us to move from working in paper and moving to a screen, right? Like, that PDF on the screen, that's just a piece of paper on the screen, right? Is that all it is? But in actual fact, we see it more as a container, or more of a filing cabinet, because a PDF can contain a whole slew of data. Metadata is my favorite one, but you can place markups on a PDF, and it could be comments, or it could be quantity measurements. You could have custom formulas built in, and all contained within that environment. Hyperlinks to link your drawings together or to outside documents, bookmarks, file attachments, images. So you're on site and you've got your PDF drawings there. You see an issue, you want to take a photo of that issue and pin it to the PDF. No problem, that PDF will hold that. Spaces, which are like Revit rooms, so they can tag everything. And finally, IFC. Something that's little known about a PDF, the PDF environment. If you have an IFC file, which is another common data environment, if you drag that into Bluebeam Revu, it will convert it to a 3D PDF, and it will carry over all of that model tree data. So you're able to actually interact with that data. So PDF is more than a one-dimensional type of thing. So, but isn't BIM about that one common live shared model that we're all going to work in? Yes. That's what would be ideal for the industry, is if we can get there. But the question always is, well, what do we do in the meantime? And so I like to use this example from my friend Nathan Wood. I've put his website up there. He's the president of an industry group called the CP Coalition, Construction Progress Coalition. It's made up of architects, contractors, engineers, owners, and their job is they're coming together to define kind of guidelines and procedures for the construction industry. But the illustration goes like this. So who came here today and navigated here or to their hotel or whatever using Google Maps? So we've got a few people that did that. And who here navigated using Google Earth? Nobody did use Google Earth. Okay, well, no one's going to argue that Google Earth has more data, right? Like, you've got the colors and the shapes of the buildings and whether they're tall or short, and white roofs or dark roofs and green roofs and all of that. Great data, lots of it. But the reason that Google Maps works is because it's the right information in the right format at the right time. And that phrase might sound familiar to you because it's actually also referenced in the Canadian practice manual for BIM that was released earlier this year when describing what is one of the core goals of BIM, and it's that you want to get the right information to the right people at the right time and in the right format. And so who here has Bluebeam Revu or Adobe Reader or any other PDF software installed on a machine? You can be honest. I'm not going to have you put down your hands if it's not Bluebeam, whatever. So maybe the question isn't so much about, when we're talking about a common data environment, maybe it's not so much about what should we try to get the industry to be using. Maybe the question's more about, well, what are we already using? And by that poll, we've just found that, like, well, most of you are already working in or can be working in a PDF environment. And so that's pretty interesting. So now we're going to get into how are other people, or maybe some people here, achieving those core benefits of BIM, collaboration, transparency, visualization. How are they doing that within the Bluebeam environment? Because it's, again, it was mentioned before, it's not about the technology. It's just about how people are able to use the technology. So that's what we want to shed some light on here today. So the first thing I want to talk about is Bluebeam Studio sessions. And what this is basically an environment where you can have 2 or more, 20, 50 people collaborating at the same time on the same document or same set of documents. And so what's happening in this example here is that we've got an architect and they want to collaborate with a contractor. Maybe there's an issue going on with the drawing. And so they're inviting them into this collaborative studio session. They could have more people on here, but for the sake of screen space, we're going to just show 2. But what's happening is they're able to access different parts of the document at different times if they like, or they can both look at the same place. So you're not on the phone saying, no, not grid line B, grid line C. No, not that bathroom. So you're able to, you know that you're looking at the same thing at the same time, and you're making comments. And while you're making these comments, they can interact with those comments, reply to them. And this is all being held within that PDF container. And so when you get to the end of it, you can create this report. And all of this data has been captured. And basically, if you've ever been to a meeting and received the minutes and found them to be a little bit lacking, you might appreciate getting a nice, clean report of all of the decisions that were made, the action items, the rationale behind the decisions, and even some of the conversation back and forth. And it's all contained. You can see it down below there in what we call the markups list. So it's just an example of not only the collaboration portion, but the data capture portion that you can achieve. Along with that idea of data, we had mentioned before about the IFC file being able to be brought into that PDF environment. This next video shows just that. So what we're doing here is we're dragging an IFC file just into the interface. It's getting converted into a 3D PDF, and you can see this person here interacting with pieces of that model. You can see at the bottom, just like it was the markups list before, this is all the model tree. So any data that was in that IFC file now appears there. They're able to select pieces, even paste 3D PDF into a 2D PDF, which gets into the mind-blowing kind of like, what? Is it 3D or is it 2D? In this case, again, working with the data, maybe the contractor says, hey, I've got this great model now. I used to have to do takeoffs, but in this case, I can just export all of that IFC data into Excel, because that's where I like to live. I like to do calculations there, and look at that. I've got all of the concrete floor areas exported out. So I've taken data from the authoring software, moved it to IFC, moved it over to a PDF, moved it into an Excel. And you're saying, well, wouldn't it be better if we just had access to the model at the beginning? It's like, yes, that would be great. But in the meantime, how many of you like to work in Excel besides me? I'm probably not the only one, but I like to get data the way I like to get data, right? So this allows for that. And so that 3D space, it's a published space. It's not a working environment, but you can do work in it. So with that, I now want to give it over to Lilia here, and she's going to explain how they were using some of these concepts in the CHUM Hospital project in Montreal.
Thank you, David, for the, Not a stall. Thank you, David, for the introduction, and thank you all for being here. So, a quick introduction about me. I'm an architect. I work for Neuf Architects. I need to go ahead. For Neuf Architects, it's about 130 person office headquartered in Montreal, and I'm the architect leading the Toronto office. So the idea of my presentation is to give you, is it okay, volume-wise? The idea of my presentation is to give you an insight on the tools, some of which David already covered, that we used while designing and building the largest healthcare project in North America, the new CHUM Hospital in downtown Montreal. So I will start by giving you a short introduction to the magnitude of the team and the project itself. The project was a public-private P3 a partnership and of a joint venture of two large contractors from the UK and Spain, and multiple consultants and sub-consultants in different offices pretty much spread across all around the world, particularly in North America. So as you can see in here, the team was very much international, and the architectural team itself was a joint venture between Canon Design and Neuf Architects. So the project itself was the finished project is about 3 million square feet, and it took about 6 years to construct. There were more than 500 consultants on the team, as I mentioned, in different offices across North America. And perhaps the most impressive number is the number of guys on the construction site. In the peak periods, it was about 2.5 to 2,800 guys daily. So if you wonder why so many people, here are a few numbers. So there are actually exact 12,500 rooms, more than 12,000 doors, and about 1 million square feet of curtain wall to install on a very, very fast track. There were more than 27,000 documents produced during the process, so the management of those was extremely difficult. And just to finish, it was the largest P3 healthcare project in Canada. So we're very proud and happy that it's finally over. We delivered substantial completion March 31st this year, and now the hospital is operating. There are 772 single patient rooms, 39 operating theaters, and next week we're expecting the first patient to come in. So just to add a little bit to the mixture of people and firms involved, in Quebec, as some of you might be aware, there is a 1% art integration program where coordination is required with the Ministry of Culture. And in our case, early on in 2011, 2012, we started that process with the Ministry of Culture to select 10 artists and integrate their artwork with the architecture. So the project of that magnitude is not easy, even in the most ideal scenario where we're all in the same room, working around the same table, sharing information, passing drawings, and talking to each other directly. So supplemented by a diagram that we received like this in 2011, how the BIM models will be separated in order to assist the workflow. It was obviously beneficial. There were, I believe, 60 plus BIM models developed and constantly being updated throughout the process. But there was still a big necessity for all of us to find a common language, a common platform where we could all talk and talk regardless of where we are. So what we did is our team was introduced to Bluebeam Studio, and at the time, obviously, in 2011, it was introduced to us by Matt Foreman. He's a very geeky guy, I suppose I could call him, from Canon Design in the St. Louis office. And he said, oh, well, we should all go to the studio. And we were all, well, where's that studio? And he said, on the cloud. Okay, so we started it, and just to make the analogy, like the way you would have the table and everyone is around the same table, the only difference here, it's somewhere out in the cloud. It's a room with a number and different people. Usually there's a host. The host could put the drawings down on the table or in the studio, and different people could come in, comment, talk to each other. So this is just to give you again a magnitude of the engagement. There were nearly 6,000 architectural construction sheets, and probably one of the other difficulties on the project, again because of the nature of the international team, was the necessity to collaborate and work in two languages, both French and English, because not everyone was bilingual. So when we receive about in the peak periods of 2015, 2016 submittals, 100 submittals daily, finding a way that the team could be reviewing and processing them fast was again a big necessity. So just to give you an example of one such collaboration, in this case, this is the RCP coordination. All of the color are the markup, and if I go closely to see the close-up, you're able to see the different colors and people talking to each other. And each color represents a different person, and people are discussing or marking up something is completed or taking actions. So this is another example where Studio was very helpful to bridge the inputs from different sources in a single common data environment. In this case, it was the necessity to collaborate with the maintenance subcontractor for the cleaning of a 3-story atrium, a glass atrium, and the integration of a monorail system and a basket that would be installed. So what we received is this. We received the manufacturer CAD drawing, produced most probably in AutoCAD, and we needed to find the location of whether we could actually fit an access hatch in our wall in order to allow for that basket to come out and clean. So at first, we knew, the first reaction, there's no way we could accommodate it, and the basket was already at its smallest size for a person to operate it. So what we did is we took, at that point, the curtain wall is well in advance of getting built. So we took you could see in the bloom, we took the shop drawings from Gamma, we overlaid them on the structural drawings, we overlaid them with the architectural details, and again, this is happening in a studio environment where we all are in different locations, and we are trying to figure out where the access door needs to be. So one thing that was very important and actually became the deal breaker was the anchors for the curtain wall. That typically you wouldn't see them in the BIM model. They only show up in the shop drawing. So being able to see that information, we were pretty much able to measure to a few centimeters away from each other, and that's what established the location of the access door, and it worked. So the next level of communication was when we got to the site. So I personally was asked to, at first I was very much involved back and forth with site, but then I was asked to relocate on site. And this is Guy, one of the superintendents leading the public space that I was heading the construction of from architectural standpoint. And he was always having questions. So being on site was a necessity. So I adjusted my schedule from architect starting at 9, 10 to 7 o'clock starting with him, and it was still not enough. So and he was always with his iPad, mostly to look at emails and look at his drawings. So I suggested, okay, what about we use Studio? So I don't need to be physically walking right next to you especially when you're taking your final dimensions for metal panels and so on. And this is an example of what happened when I was in I was going back to Europe, and I was at the Frankfurt airport waiting for a connecting flight. And Guy puts this in the studio, this image, and a few minutes later, he had marked this up. This is all markups with polygons in Bluebeam. And what he was trying to explain to me, he's almost done measuring his metal panels, but he encountered a problem, and you could see it here in the French text on top. He's trying to tell me that the mullions on the two sides of the corner are actually at different heights, so he needs a direction what to do. And here he's concerned that there are too many butt joints. Please note the way his English was not perfect, but it was pretty good. My French is not perfect, so we got along just fine. And so I logged in, and I sent him back comments what to do, what to eliminate. And then in a few minutes after, he responded back, and this is Guy just learning to use Bluebeam and collaborate. So every time he would send back a comment, he was using a different color. So you can imagine by the end of it, there was barely any picture left to look at, and I barely had a chance to read what he was actually writing because he was using strange colors. So this was the site coordination, and the last point I'm hoping to touch upon is the way we saw the future, and mostly BIM. Beyond BIM and the future. And this is a document coming from the World Economic Forum, and I highly recommend it. Was published in 2015 for you to take a look at it. And what it was talking about is the time has come for transformation. So this was a pilot project between the University of Oslo in Norway and Skanska, a large Scandinavian contractor. And what they tried to do is figure out how to bridge that gap of all this 3D information that's being created during the design phase and how to take it to the construction site. So at that point, I had heard about 3D PDFs, but I had never used them, and we were well in advance with most of the drawings. So I thought we would implement them in some of the more complex spaces. So what we did, I will skip these because I think I'm running out of time. This is just a summary of what the document says. The document is identifying that that we need to find the better ways to visualize what someone is imagining in their head, because in reality, yes, we have moved in a very digital world nowadays, but the actual output that architects put out there is still two-dimensional, and in most cases, it's drawings that would have been the same if they were produced in the 80s. Just the line weights are not as nice, and they're not as clear because there are overlaps of things, and so in a way, even pencil drawings might have been better. So what we did is this was the first attempt to implement it, and now I would say we are getting better. Where we had the 2D information, we did it for the feature staircases of the hospital. There were a total of 7 of them. They were often complex geometry, and alongside with the 2D information, we included a little 3D snapshot, which just looks like a 3D axle of something. But then when you click on it, it's actually a 3D model. So it brings you, we always obviously put the note, it's for reference, because I don't think, at least to my knowledge, you're not able to dimension things from here, but you could spin it around, section it the same way you would section a model, and you could open this, you could do horizontal cuts, and you could open this on your iPhone. You don't need any specific software. Any person with an iPhone, iPad, or so on could open this model. And this is another example where another staircase where we implemented it. In this case, it was very useful because the stair is very complex geometry, and as you could see, these are the RCP drawings. Often, a stair is already difficult to represent in two dimensions. When you have the RCP on top and multiple landings not aligning with each other, we encountered that the electrical guys on site and the sprinkler guys had no clue where to position the lights. They were seeing something diagonally, and they couldn't really see where the dimensions lines were. So they started using the 3D PDF, and immediately after they were able to spin the 3D PDF, even for a few seconds, the RCP drawings started to make a lot more sense. And then this is the final bit that on another project we're doing, where this was early on. We started with the BIM model and we sent it to the cost estimator. And what was really useful is the estimator guy was able to select an element, and all the data that comes from the BIM model is stored in the 3D PDF. He doesn't need to possess, again, any software to really read it. Adobe, Bluebeam, any of those are able to open the file. But on the side, you're able to see the area, the material that has been specified, the height of the element, and be able to, and you could also generate an Excel spreadsheet to satisfy David, and use that information for cost estimation. So I think this is it. I just want to finish on a last note. That's something my mentor told me, that the essence of our industry is communication, and there's something magical when you allow somebody to see something that, as an architect, you've imagined. When you allowed someone else to enter that world, that person takes a lot more responsibility, and it's just a lot nicer process to go through. That's it. Thank you.
So we'll take any questions, but I did want to end with, there was a comment earlier about this whole like the number one challenge of BIM being this culture transformation. And that's really why I wanted to speak with Lilia today after seeing what they were doing on this project, because yes, we want to get to that ultimate goal of BIM being widespread. But what's happening here is that Lilia and her team were part of that culture transformation. Like Guy on the site, would he have ever looked at a 3D PDF before, or would he ever done real-time collaboration if she hadn't introduced him to these things? But now the comfort level of a wide number of people are that much closer to being, again, more comfortable with maybe actually opening up an actual model and collaborating in real time on a shared model. So that's where we see one of the benefits coming through for sure for the industry. So if there's any questions, we'll take them, or you can talk to us afterwards, just to keep the flow going. Oh, question. I was hoping you have a question for us.
I know.
Yeah,
I've been full of them today. So, anyways, as you were talking about, just collaborating, and also brought up that study with Skanska, I believe, was on there. What is the common pushback that you get from construction companies that they say, hey, we don't really want to waste our time getting into 3D PDF modeling or other new technologies?
I think the common pushback, actually, the number one thing is just not knowing what's available. So it's not so much that there would be necessarily a pushback for a 3D PDF, for example.
Okay.
But like, how many people here that was the first time seeing a 3D PDF? Okay. Well, one guy's honest. But on the job site, for sure, like, well, why would I need that?
Right.
And so the pushback is like, well, we're doing well without it already, so why do we need something new?
Right, and that was more for, I guess, the project managers, where I'm sure everybody in here, VDC and BIM knowledgeable, so yeah, they
Sure.
do know everything in here, but it's more of dealing with the groups outside or beyond. So,
Yeah,
yeah,
for sure.
cool. All right, thanks.
Yeah.
Thanks, guys.
Thank you.
Okay.
That was good.
All right.
Thank you. Right on.